Hello everyone. Today we wanted to have some introduction about the PowerWorld simulator, which is a kind of software we use it actually for power system analysis. However, um, before we talk about PW or PowerWorld, let me tell you that we have different kind of softwares in the market. We have ETAP. It's quite famous software, so it can be used actually, in transmission companies, oil and gas industries. Well, many of oil and gas industry, maybe they use ETAP software. We have SIME, we have DINIS, we have IPSA, PSS. We have, of course, PowerWorld, which we talk about it. We have NEPLAN, EMTP, PSCAD, and of course, Silent. So there are, some other softwares which they are common as well, but we didn't have, basically enough space here to mention all of them. But I want to tell you, each and every software has got its own advantages and disadvantages. Well, many of the softwares right now are used for power system analysis. For example, ETAP, SIME, PowerWorld, Silent. So these are some of those softwares which transmission companies they use them actually, for analysis over the power network. But there are some software like as EMTP, which they are very common actually for basically transient analysis. EMTP and EMTP-RV, these are the softwares actually for transient analysis. All of them, so I can tell you that are quite useful. However, today we wanted to talk about the PowerWorld, which is quite, basically, well, very straightforward software, so it can be used for power system analysis one, and for simple analysis, it's quite actually, basically user-friendly software. However, so I'm telling you that ETAP, SIME, these softwares, Silent, these are very common for large network, and when we wanted to have power system network analysis and evaluation. Talking about PowerWorld, among the softwares which they are available in the market, here is the environment of the PowerWorld. So of course, similar to the other softwares, PowerWorld has got its own menus. So you can find some top menus here. So you can find some shortcuts here, and it's got actually some side menus. Well, we are working very usual, and we use actually these two vertical menus here, which one of them is the edit mode and the other one is run mode. So edit mode usually use when we're gonna to edit or when we wanted to draw actually our single line diagram inside the software. And run mode is come on when we're gonna actually to run and we're gonna to operate this system and solve the single line diagram which we have been drawn it here in the edit mode, and we're gonna to operate this system, we're gonna to run the software. So I don't want to go to, and I don't want to very in detail discuss today because this is just introduction and we wanted to look at to a simple example. But to introduce you actually this software, let's go ahead and let's see how we can perform or how we can model a simple single line diagram here and how we can actually run it to get the result from this single line diagram and perform analysis. So to perform or to model our actually single line diagram in this software, so at first we have to select the edit mode, which you can find it here in the left side in the vertical actually menu. I call this one vertical menus and these guys actually horizontal menus. So to create a kind of new model, of course the first thing is we go to the menu of the file, and similar to the other software we will find number of actually menus here, sub menus here. So many of them you're familiar with them, but so to create a new case, of course we will select a new case. So if previously you have created another case, the system is asking you would like to save the previous case, which you can say no, and then it will create a new case for you. You can say yes to save the previous cases. So I've got this message because previously I have completed a model so over this software. Right now we are in the environment that's the edit mode environment of this specific software. And in the edit mode, the first things which we're going to do is, of course, we're going to model our network. So to model our network, you will find a number of menus here, and the most familiar for drawing is, of course, draw menu. If you press draw menu, you will get some shortcut here, which I don't want to discuss about each and every shortcut specifically right now. I'm going to straightforward talk about the network drawing. So, and then you can find the sign of the network here, the name of the network, and of course a specific sign of a bus bar here. So if you press network, you will find different component here. So these are common components which we are using to draw a single line diagram. So of course we have bus, which can model bus bar for us. We have generator, load, switch, shunt capacitance, the model of the transmission line, transformer, series capacitor. So if we're going to perform DC transmission line, we have a model of DC transmission line. If we need to have a 3-winding transformer, so basically we can use 3-winding transformer. So basically fact devices, and of course different topology. But I want it to be very simple, and I want to draw a simple single line diagram in this introduction session. So at first I will select the kind of bus bar, because if I'm going to create actually a network, I will start actually to draw it from the first bus bar, which can be our slack bus bar. So if you select actually the sign of the bus, so then you will see that you will get a cross sign over actually the environment, the edit mode environment of the PowerWorld. If I click right now over the edit mode environment, so this menu which is related to the bus bar would be pop up. So which you can set different parameters so for your bus bar in this specific menu. For example, you can give the nominal voltage, so the area, balancing, basically zone, owner of this bus bar. So some of these information coming from industry. I mean, when you're going to model a kind of industrial case, of course you have some of these information, but we are supposed that just we use this one for the power system analysis course. That's why we're going to be very simple, and we just give a bus name to our bus bar. For example, I'll call this bus bar bus 1, number 1, and basically for bus bar information, I will set this bus bar to be slack bus. Well, we will explain about the slack bus bar later, but so for now, please know that we need to have one bus bar in entire the system to be a slack bus bar. I will explain this one later in the lecture, that what is the reason that we need to have this slack bus bar. So, of course, there are a number of parameters. I don't want to explain about them right now, but later we will discuss about each and every one. And I'm pressing OK, so to set the first bus bar. So you will get this bus bar actually, in horizontal mode. Of course, you can change the size, and if you're going to make it vertical, you have to double click on your bus bar and you go to the display mode, and you can put it right, orientation right, up, left. For example, if you put it up, then it will become vertical. So, well, you can put it vertical or horizontal. That one is not a big deal. It's just for demonstration. Well, I will make it again horizontal. I'll just double click on that, go to display mode, and display menu, and I'll put it right and then click on it. Well, now I'm going to add a kind of generator. So let me put this number here. Yeah, 1. So again, I'll go to drawing part, so network, and now I'll select generator. So I will select generator. I'll come over this bus bar and I'll double click here. So then I'll get another menu, which is related to the generator options. So inside of the menu of the generator options, you will see different actually, parameters requested to be inserted. However, because we're going to be fast in this introduction, actually, video, we will put some value or power value megawatt for our generator. Let's say we put 500 megawatt to be the set point. So basically of our generator. Later we'll discuss about the other parameters. So and how we can actually play with them. If I'm pressing OK, so this generator would be connected actually to this bus bar. So I will go and select another bus bar because I wanted to connect my load to the new bus bar. So for example here, and I double click on that. So I will call it bus bar 2. And then I'll press OK. So and there is a nominal voltage of your bus bar here. So you can change, of course, this voltage. And if you change this voltage, of course, you have to put transformer between your bus bar if you got different voltage levels. So this is becoming second bus bar. Right now, I wanted to add a load. So this one is the load. I will select the load. I'll come over the bus bar, exactly over the bus bar, and I'll double click here. If you double click here, the load options would be requested from you. So that's a megawatt value for your load. Let's say 100, for example, 50 megawatt. It's a typical example. So, and again, it's got different parameters, which we'll discuss later. But, for now, please accept this 150 megawatt. And this load would be connected, to my second bus bar. If you're going to change the size, so you can come here, display size. For example, you can make it a little bit smaller, so to be more visible in your screen. So right now I have bus bar 1, generator, 1 load, and the second bus bar here. So you can also, connect a kind of shunt capacitor, which is called switch shunt, to your second bus bar to be able to support the reactive power of your load. So, and then you will double click again. You will say nominal megawatt value, for example, let's say 2 megawatt for this, shunt compensator. So, and then I will press OK. So let me adjust the size of this shunt component as well. Yes, to be more visible. And then I'll put another bus bar because I wanted to have another load. So another bus bar, I call it bus bar 3. You can put a number here, it doesn't matter, but I'll just put it 1, 2, 3, as the name of my bus bars. And the voltage is supposed to be 130 kilovolt and to be horizontal. And that's it. And I'll bring it here a little bit closer to this bus bar. And then I'll connect another load to that. So again, whatever I've done for the second bus bar, I'll do it here. And I'm putting, some value for the megawatt, let's say 100 megawatt, for example. And then I'll press OK. Oh, let me change the size as well. You can change the size from here as well. You see, dragging that. But anyway, to have the same size. So you can change it from here. Number 8, I think we put the last one, number 8. Yes. Okay. Right now I wanted to connect these bus bars together. So the slack bus bar to the second bus bar, I want to use actually kind of transformer. So I'll select the transformer. I will, press just one single click here. So you will see that a kind of line, will become visible. You click again here, then you can break your line. You click here, you click single click here, and then when you reach here, you can, stop over the bus bar and double click here. If you double click here, so basically the information regarding your transformer, the menu regarding your transformer would be pop up, and the system is asking you to insert the reactance. And then you need to put the parameters of your transformers. So let's say here, so basically for our transformer, so for example, we can put as a kind of impedance 0.1, and this value would be based on per unit system. It says that per unit impedance. And the MVA limit of your transformer, because your generator is 500, you can put 500 MVA. So there are different limits, which we'll talk later, and there are different options, which we'll talk about them later, but these two information are enough right now for simple simulation. And then you'll press OK, so you have created your transformer, right? So between these two bus bars, I wanted to put a transmission line. So I'll go here, select transmission line, put a single click here, one more time, transmission line. I'll take a single click here, I'll get this line, another single click here to break the line, another single click here, and then I'll stand over actually the third bus bar and double click over there. So the system asked me right now to provide information about the series reactance. You see, these series reactance, shunt charging, series resistance, these are all the parameters which we will discuss them in chapter 4 and chapter 5 of our book. When we are talking about actually inductance calculation, capacitance calculation, inductive reactance calculation, capacitive reactance calculation, we'll discuss how to calculate these parameters, because these parameters are quite important. Anyway, as a kind of sample, I'll put 0.1, and for the limit of my transmission line, I'll put, for example, let's say 500 MVA to be on the safe side and not get congestion or saturated with the load. So, and then I'll press OK. So more or less our model, our simple model is ready, and we're gonna to run it right now. So to run or to operate it, to simulate it, from the edit mode, we have to go to the run mode. And if we go to the run mode instead of the edit mode, so there is a specific, menus here. So if you look at these menus, of course, each and every menu has got its own task. We'll discuss later. But there's a specific menu which we call it tools menu. So over the tools menu, so there is a specific button here which you call solve. And if you open the solve, you will see different method of analysis here. So we'll talk about these methods. At least two of these methods would be taught actually in this semester. So Gauss-Seidel or Gauss-Seidel method and Newton-Raphson method. These are the method which we will explain them in detail in this semester. So and you can use your method of solving. For example, let's say Gauss-Seidel method. So I'll press this one. And right now, if I'm pressing actually this button, which everyone knows that, of course, this is play. So you will see that my system start. Basically, to show the power flow from my generator side, so towards to the load side. So either it's going to be load 1 or load 2. And you see basically some bars here. You see these green bars? So if these green bars are larger, so it means that more power is flowing from this line. And if they are basically smaller, so something like as this one, in terms of the size, so it means that less power is flowing from here. And if you get very close to the overload, so the color of these bars would be changed from green color to red color, and you will get some warning, over your software, of course. And if you're going to see that how many percent your transformer or your transmission line are loaded, that's enough. If you double click on the sign or over the sign of your transformer, and then you select actually, always show value in person. By the way, let me tell you something. Just few minutes before, when I wanted to draw the transformer in the edit mode, when I wanted to insert the parameter of the transformer, I actually inserted the parameter of the line which is connected to the transformer. And I put the series impedance of the line, and then I put actually, the megavolt ampere rating of the line. But it was automatically set for my transformer, those information. So that's why you can find it here. So that megavolt ampere rating is set for 500 MVA for my transformer. So that's the case, which automatically would be done in this software. And if I press OK, then you will see actually that my transformer is right now on 50% load. So, and we do the same with the transmission line. I'll double click on this, and then I'll press always show value in percent, then I'll press OK. And 21% of my transmission line is right now loaded in this, condition. So I can stop it. I can get back to the edit mode, double click on my load, and from 100 megawatt, for example, I put it 110 megawatt. So this can be done automatically as well. I mean, you can design it in a way which with the bottom you change it. But anyway, let's do it manually, 110 megawatt, and we'll get back to the run mode again and simulate it again. You will see. So transformer became 52%, loaded, and the transmission line is 23% load. By the way, you can bring it a little bit, this side to see the parameters of your load as well, and the entire the parameters. So basically over your single line diagram. Well, this system is right now working properly. Let's look at to another example, which this example has got ready with the PowerWorld company. This example has got ready with PowerWorld company. Well, we have a generator which is generating right now 5.1 megawatt, and the load is 5 megawatt. So if I run this system, you'll see the power dispatch from the generator side to the load side. So there is an automatic interface here, so you can increase the load, or you can probably decrease the load. If you increase the load, you will see basically this pie chart shows how your line is occupied. So I can increase that. You can double click here and press always show value, and you see the percentage. So basically for your transformer and line. And one more things which I wanted to highlight for you. If you increase the load, you see the voltage of the bus bar, would be dropped. You see, 10 megawatt. If I increase the load, so this basically reduction or this voltage drop is of course due to the impedance of the line and of course transformer. So if you increase the load, more current will flow through the transmission line and your transformer, and that current times the impedance of your transformer and transmission line will create of course more voltage drop over your bus bars. And this bus bar, for this bus bar, there are some limitations. So if you get here, so it says limit monitoring. If you press basically this tab, you will find information over your bus bar. So low limit value, high limit value, and of course the value which your bus bar has been taken right now in this condition. So you can adjust all of these parameters when you are designing your single line diagram. So thank you very much. I hope you find this introduction about the PowerWorld software useful. Have a good day.